Okay, you guys get to listen to Mrs. Vibber because she's not here. Talk to you about side angle side and SSS similarity. Now, we're skipping a section, so we were about to do pages 29 and 30. We are skipping that and doing 30 and 31. So I need you guys to all get out pages 30 and 31 in your yellow packet. Make sure you're on the right ones. It's day 13. And I'm going to try and go through this pretty quick so you guys have time to work in class on everything that you need after this. So yeah. So the first exercise here says, in the diagram below, I am telling you that triangle ABC is similar to EFG, and that C is 120, and that F is 15. Side AB is 20, side EF is 10, and side AC is 8. Find the measure of angle E, find the length of EG. Okay, so if I were there, I would let you guys work on this on your own, but since I'm not here, I'm going to walk it through with you. If you feel like you understand this, feel free to mute me in your brain for a second and move ahead. But if I want to find the measure of angle E, I have to remember that similar things have all congruent angles. So if C right here is 120, then G is also 120. And if F over here is 15, then this is also 15. And then I can say 120 plus 15 is 135. E is going to be 180, take away 135, which is 45 degrees, which would also make A 45 in case I needed it. And then it says find the length of EG, and if I'm going to do that, I'm honestly just going to use my noggin and say that the second triangle is half the size of the first triangle. So if AC is 8, EG would be half of that. So EG is going to be 4. Ta-da, done. Okay, cool. Now, moving on. What we know so far is that with triangles only, by the way, if you have angle in two triangles, then the triangles are similar. Okay, but if you don't have angle, we haven't said that they're similar. So we've kind of had two understandings for similarity. We said if you can find all the angles, show that they're the same, and then find all the sides and show that they're proportional, the triangles are similar. Then we reduced that and said, well, you know what? If you only have two angles, that's good enough. Well, what if I don't have two angles? What if I have only one angle? Or what if I have none of the angles? Can I still establish similarity? And the answer is yes, you can, in two very specific circumstances. So one of those is SAS similarity. To prove that two triangles are similar, it's sufficient to show that two sets of corresponding sides are in proportion, and the angles they include are congruent. So if we can show, for example, down here, I'm going to put some numbers on here, that let's say like AC is 8 and DF is 4 and AB is, 18 and DE is 9. And I know that A is congruent to D. You see how I have side, angle, side again here? And up here I have the same set of side, angle, side. If I can show that not only do I have that set up, but that 8 over 4 equals 18 over 9, if I can show that there's a proportion, then those triangles are similar. Well, let's check. 8 divided by 4 is 2. 18 divided by 9 is 2. Yeah, those sides both got doubled, so I kept the same angle and I doubled the two important sides. Therefore, this is SAS similarity. Okay. So, what does that mean down here? Given the diagram below, is ABC similar to DEC? Okay, so ABC, DEC. So A is here, and they want A to correspond to D. That's important. So I'm zigzagging this. And they want B to correspond with E, and C's in the middle. Cool. Are these similar? Well, if you want to know if things are similar, you should always look for AA first. So I'm going to look for any angles. Well, I have some vertical angles right here, but I don't know about any parallelism, so I can't mention anything about alternate interiors. I'm stuck. All I have are those pair of angles right there. Now the other things I have are sides, which is great. So now I'm going to compare corresponding sides. 20 corresponds with 5. And 12 corresponds with 3. And notice how I did left triangle, the right triangle, left triangle, the right triangle. Now let's see if that works. 20 divided by 5 is 4. 12 divided by 3 is 4. Yeah, that works. So I would say triangle ABC is similar to triangle DEC because angle ACB is congruent to angle DCE because vertical angles are congruent. And the sides that include the angles are proportional. So we have SAS similarity. All right, I'll take a minute to let you guys jot that all down. So SAS similarity just says if you can't get two angles, get an angle in the surrounding sides, and then that would mean they're similar. But this time, the surrounding sides don't have to be congruent, like in SAS congruence. They have to be proportional. Once I have similar triangles, by the way, you know that the remaining sets of angles are congruent, and you know the remaining sides will be in proportion. So once you establish similarity, then you can kind of use almost like a CP-CTC thing, but for similarity, we'll talk about that later, to talk about the other angles and sides when needed. All right, now, what if you don't have any angles? If I have these two triangles, and I realize, again, I'm just going to make up some numbers here. Let's say that's 3, 4, and 5. And let's say that these are, you know what, let's make it 30, 40, and 50 and make my life easier. So let's say this is 30, 40, and 50. And then let's say this is 3, 4, and 5 because it shrank. If all those sides shrank by the same proportion, even though I don't have any angles, then I know a dilation occurred, and I can say that those triangles are similar. So if I can show that 30 over 3 equals 40 over 4 equals 50 over 5, that would be SSS similarity because the three pairs of sides shrank by the same amount. So that's 1/10 the size. Yep, this is SSS similarity. Okay, so if two triangles have all the sides marked and you recognize that all the sides got multiplied or divided by the same thing, those triangles are similar too. So number 2 says, which of the three triangles, if any, are similar and why? So if I look at A and B first, I'm going to compare short, middle, big to short, middle, big. So in this triangle, short, middle, big is 3, 4, 6. And in B, short is 8, middle is 12, big is 16. So is 3/8 equal to 4/12 equal to 6/16? Well, 3/8 can't reduce, so I'll leave that the same. 4/12 is a third. Is 3/8 a third? No, not at all. So these are not similar. A is not similar to B. Okay, let's try B to C here. So if I work with B to C, I'm going to use a different color here. So is B similar to C? We're going to find out. So I'm going to do short, middle, big. Short, middle, big for B is 8, 12, 16. And for C, 4, 8, nope, 4, 6, 8, pardon me. 8 divided by 4, 12 divided by 6, 16 divided by 8. Those are all equal. They all equal 2. So yes, B is similar to C by side, side, side similarity. Ta-da! All right, number 3. Whoops, sorry. Number 3 is the last example, and then you get to start your homework. Are the corresponding sides of these two triangles proportional? Show the work that leads to your answer. So are the corresponding sides proportional? So let's try it. Well, what two triangles are there? I see triangle ABC, and I'm curious as to whether it's similar to A, B prime, C prime. So if I want to compare sides here, I would be comparing 4 would be the short side of ABC on the left, and 13, because I need to use that whole length. Okay, so 4 and 13. And I would want to know if that's equal to 3 to 9.75. Okay, well, is 4 to 13 equal to 3 to 9.75? I don't even know, so let's pull up a calculator. I can't do this one in my head. So, have a holly jolly Christmas. Okay, so 4 to 13 and 3 to 9.75. Look at that, they are the same. Cool. So 0.307. So I'm going to come back here and say, yeah, these both equal 0.307. Okay. So yes, the sides are proportional. Now notice this is just SS, so I don't have SSS similarity. I only have 2. But you might be noticing that part B says, are the included angles congruent? Well, the included angle is that one up top. So yeah, angle A would be congruent to itself by the reflexive property. Which means when all is said and done, I have 2 sides and the angle in between. So triangle ABC is similar to triangle ABC' by SAS Similarity. Okie dokie. All right, so your homework is the day 13 homework in your blue packet. I got to admit, I don't know what page that is, but you can find it. Day 13 homework in your packet. All right, and then I'm actually going to be quiet for a second, and I'm going to pull up the answers to last night's homework so you can really quick check those before you start tonight's. So here are the answers to last night's, your angle bisector and side splitter stuff. And I'm going to be quiet and leave this up here for like 5 minutes so you can check it. And once you're done checking, you can start your homework. Okay, I will see all of you guys tomorrow. Get your homework done, and we will have our little secret Santa gift exchange party. See you then.